Okay, guys, Unit 2B, Day 5. We're looking at vertical stretches, vertical compressions, horizontal stretches, horizontal compressions. And what we're going to do is just go over, today we're going to look at a graph of something and look at it and say, okay, this has been stretched or compressed from the norm. Let's come up with an equation that makes it a vertical something and an equivalent equation that makes it a horizontal something. So you can always, so if I have something like this, let's just use a basic parabola, and I start from this one, and I want to go from this guy here to the one on the outside, I can either stretch it horizontally, or I could have compressed it vertically. Either way, I'm going to get the same scenario. So we're going to play around with that, but first we want to talk about vertical stretch and vertical compression. These two guys are not equal. I'm going to show you on decimals how they're not equal in a second. But we got to ask ourselves, how do we remember if it's horizontal or vertical? And the easiest thing to do is to look for the horizontal. Over here, you ask yourself, is this coefficient, is the number here on the x, or is it on the entire function? And if you look here and you say, look, there's 3 times x, so it's 3 times x. Well, it's not. It's 3 times x squared. So the base function here is x squared. Am I multiplying by x squared, or am I multiplying by x? And here I'm multiplying right by the x. If that's what the situation is, you know it's horizontal. If it's horizontal, you have to put it 1 over 3, because this is your k, and your compression or your stretch is 1 over k. So it's 1/3. If it's 1/3, that's less than 1. That makes it a horizontal compression of 1/3. Okay. Here, I'm multiplying right on the x squared, which makes it vertical. Okay, so I'm right on the function. X squared is my base function, my f at x, if you will. I think I was trying to sound smart there, if you will. But anyway, that's vertical. Vertical, you don't flip. That's your a. A stays as 3. So vertical, 3. 3 bigger than 1. It's a vertical stretch of 3. Okay, these guys won't look the same, and I'll show you real quick with Desmos. The first one is 3x squared. Let's launch this calculator. So the first one is going to be, let's go over here again and go in projector mode. The first one here is 3x squared. So it looks like that. And this one here is bracket 3x all squared. So give me a second. Blue. And you notice that they are not the same. Okay, one's got and the difference is, are you squaring the 3 or not? So in today's class, we're going to look at something, an equation, and then we're going to come up with its horizontal and its vertical stretch or compression equivalent. So these guys are not the same. Could we come up with equations, a horizontal compression that would, so this one here was our vertical stretch. Can we come up with a horizontal compression that will make our something equivalent to our red parabola? Yeah, we can. And let's play around with that today. So the first one, let me go to your notes and add a second page to this. And let me just grab your notes here through my notes to find your notes. And the first one I start off with is your basic line. So your basic line, you're going to have something like 5x. So 5x, the line gets kind of irritating. So 5x is based off the base function f at x equals x. Now the question is this 5 on the function? So this is g at x. Is this 5 on the function, or is it on the x itself? And for a line, to tell you the truth, it doesn't really matter. So when you have option 1 and option 2, okay, in option 1, we're going to put the 5 right on the function. So it's 5 times the function of x. So this you'll have 5 times f at x. Okay, so that's 5 times f at x, and that's then going to make it a vertical stretch of 5. Okay, because it's a 5. That makes your a 5. If a is 5, if it's vertical, you multiply right onto the function. If you multiply on the function, you do not change the sign. So 5 stays as a 5, or you don't change the size, sorry. You don't make it 1 over 5. It's 5. 5 is big, so it's a vertical stretch. Here, you could come back and say, no, this is 5 times x. So the 5 is right on the x. That would be the equivalent of saying that I am multiplying x by 5, and that makes it a horizontal transformation. And if it's horizontal, I want 1 over 5. Okay, take this horizontal, always 1 over. 1/5 is small, horizontal compression of 1/5. And then if you graph these, they're the exact same thing. And that's the whole point is, can I take this and stretch it one way and compress it the other way and end up with the same thing? So if I had my original line that looked like that, and then I said, let's stretch it by 5, I can stretch it vertically by 5 and get a line that looks like this. On the other side, what I can do is I can compress it horizontally by a factor of 5. So all these points are now 1/5 as big as they were, and they will come in like this. The vertical will affect your y. So if you had a series of points here, your points are now, so if I had 0, 0, and 1, 1, my new points are going to be 5 times as large. 0, 0 stays the same, and my new second point will be the point 1, 5. So the old point here that was at 1, 1 will be pulled up 5 units, and therefore stretching it vertically. Here, you're going to affect your, because it's horizontal, you're going to affect your y values. So I have 0, 0, and I have the point 1, 5, and they still stay as 0, 0 here. And this one here now, what you're going to multiply the x values by 1/5, because this is my k here, 1/5. So this will give me 1/5, oh, sorry, 1, 1 here. That will give me 1/5 one, which means that I go over just a tiny bit, and then I go up 1. And in that case, you'll follow it, and you'll end up with the exact same line. So that's how you look at lines, and lines are a pain. But let's go on to something a little more interesting. And let's go on to, we can go on to what we did in B here, 9x squared. If f at x is 9x squared, I want to look at this and say, is it horizontal or is it vertical? Well, in this case, we can look at it 2 different ways. That's 9x squared. That's the same as 3x all squared. And how do I know, what am I doing here? I'm taking the root of this whole thing. So 3x all squared, if I expanded that, would be 9x squared. 3x times 3x, 3 times 3 is 9, x times x is x squared. So I take the root of this. So I have 2 different equations. One is 9x squared, and if I have 9x squared and the other is like this, bracket 3x all squared. 9x squared, here, let's go to this one first. The 3 is right on the x. If the 3 is on the x, then what I'm doing here is I'm making a horizontal transformation. 3 on the x, so when I write it in function notation, the 3 goes right on the x. If the 3 is on the x, then it is horizontal. If it's horizontal, I need to flip this to 1/3, and if it's 1/3, it's a horizontal compression of 1/3. Over here, the 9 is on the x squared, so it's 9 times x squared, so it's 9 times the function, the base function of x squared. If it's a vertical, so that makes it vertical, that's your a value. Your vertical, so it's vertical of 9, don't make it 1/9, it's just 9, and 9 is bigger than 1, so it's a vertical stretch of 9. So that's how you know, how you compare the two of them. And now let's go back to our Desmos over here. If I go to Desmos, I had 3x squared, I had this one, the blue one stays the same, and now let's see if I can make this guy here look the same as the blue one. I put 9x squared in there, and believe it or not, I erased it, but it doesn't matter. You notice that is the exact same. So I had 9x squared, and that is the same as, let's go back to this, 3x squared. Oh, throwing my pen around here. What did I just do? 3x all squared. So the green guy goes there, and if I want to make the red guy disappear, I just click on that, and the green one disappear, bring the red one back, bring them both together. They're the exact same thing. Okay, so those are equivalent there. I think we did we do another root? I think we did do a root in class. Let's see, search comparison. Part C, yep, we did. So let me go over this. Really quick, we'll do the exact same thing with the roots here. We start with the base function of f at x being root x, and then I have this root 16x, and I'm asked what kind of translation, what kind of transformation, not translation, transformation. Well, that is, let's just write the equivalent of this. Root 16x is the same as 4 root x, because if I get root of 16, the root of 16 is 4, so they're the exact same thing. I have here, I have 2 different equations that are the exact same. One has a 16 right on the x, so if the 16 is right on the x, so that's 16 right on the x, so it looked like that, 16 right, so this is function notation. I take the root x out, so there's no root here. Be careful when you put function notation. F at x is equal to root 16, or root x, sorry. So if I'm going 16 times x, I'm going 16 times what's under the root here, so 16 times x here, 16 times x here, and that's what turns into this. That is 16 times x. The 16 is multiplying right on the x. Everything on the x or everything in the bracket is horizontal. If it's horizontal and it's being multiplied, do we know if it's a compression or a stretch? We don't know. We flip it, so it's 1/16. That becomes a horizontal compression of 1/16. Now, I think everything we've done so far has been a horizontal compression. So let me just pretend this turned out to be, I don't know, 1/16. If that was 1/16, you would flip this, and that would become 16. that's bigger than 1, and that turns into a horizontal stretch of 16. Okay, but let's go back and finish this question to match our notes. Okay, so it was 16 here, and 16 turns into 1/16, and we have a horizontal compression. Okay, here, K, remember for letters will be a bigger part later. We'll talk about AK and DC in a bit. This is the second version over here, 4 times the function. So 4 times the function, f at x. So 4 times the function. 4 times the function. If you're multiplying by the function, it's vertical. If it's vertical, you don't change this to 1 over. It's just 4. 4 is bigger than 1, so it's a vertical stretch of 4. You can graph those. Go ahead on Desmos, and you'll see that they are exactly the same. Okay, hopefully that helped out, clarify the note if you had any issues with the note. And that's about it. Okay, take care.